So in this video, we're going to talk about other parts of circles. So we've spoken about chords, diameters, radii, etc. But there are other parts of circles that you see, but we don't necessarily have the vocabulary for it yet. What we're going to talk about are arcs and central angles. An arc is the piece of the circle or a piece of the outer edge of a circle. So if I look from here, so looking at the curved piece of the circle from A to E, that is an arc. So that piece, so it's the piece of the circle between any 2 points on the circle from A to E, that is an arc. If you look at it, AE it's a small piece. It's what we call a minor arc, okay? And we'll name it like this. So similar to how you might use a segment, instead of a straight line, we're going to use an arc. Okay, a minor arc is defined as an arc that is less than 180 degrees. If you look, someone noted this in class, that a full circle has 360 degrees all the way around. Again, so a minor arc is less than 180. Conversely, a major arc is a piece of the circle that is larger than 180. So for example, if I were to go from, let's say, from A all the way around to F, say that chunk, that would be what we call a major arc. Now you notice from A to F, if I were to just call it AF, I'd be referring to the minor arc. AF is the minor arc, which is the segment here, this piece here. So how do I call, or how do I name the piece, the major arc that we highlighted in the purple? Well, to name a major arc, you'd have to use 3 letters. The first and last letter, so A all the way to F, have to be the endpoints, and then the letter in the middle can just be any point between them. So I could either call this major arc A, E, F, or I could call it A, C, F. It's still referring to going around the circle. So I'm just going to call this one ACF. If I were to refer to a semicircle, so remember a whole circle has 360 degrees, a semicircle would only contain 180. So whereas a major arc is more than 180, a semicircle equals 180 degrees. That's exactly half. The semicircle, so if I were to erase the markings I've made on this so far, and put the names on, so this is A, C. A semicircle is exactly half. So from here to here, that's half of the circle. The way that I know it's half, well, first of all, I'd have to know that B is the center. So let's say I gave you that. This is the circle. So it's cut exactly in half. That segment that I just highlighted is the diameter. So in order for an arc to be a semicircle, the endpoints have to be the diameter. So the endpoints are on the diameter. Okay, and then to name a semicircle, because you'll ask, well, if they're exactly the same, how do I know which side I'm referring to? So I'm referring to this side of the semicircle. I can call it AEC. And the other semicircle that's contained in the picture, well, the other side, I can call that AFC. F is a point on there, so AFC. Those are 2 semicircles in the picture. So again, to review, AE is a minor arc. So was AF. There are other minor arcs in this picture. You should take a look to see if you can figure out any others. Other minor arcs are F to C, even E to C. They all just have to be less than 180. So if you look, if it's less than a semicircle, then it is a minor arc. If it's more than a semicircle, so if it contains a semicircle and then some, so look all the way from A to F this way, right? A, which we called ACF, that was a major arc. If you go around the other way, from A to E that way, sorry about my bad drawing, that's also a major arc. Okay, so there are others in the picture. So I'll name another major arc, AFE. That's going the other way around. That's another major arc. Okay, and let's talk about semicircles. We name them with 3 letters, similar to a major arc, but the endpoints have to be on the diameter. When we measure an arc, they're measured in 2 ways. We measure it in degrees, and then we'll also measure it in units. We're just going to talk about degrees in this video, okay? So you saw me speak of the semicircle, where the semicircle was 180 degrees. If you think 180 is half of 360, that 180 degree arc, it has a relationship with that diameter. If we were to look at the diameter of a circle, so let me draw a circle. Okay, so if I draw a circle, let's call this circle A. And if I were to construct a diameter, okay, so if I were to construct a diameter, remember a diameter is a chord that goes through the center. If I asked you to tell me what's the measure of angle BAC, you would tell me that was 180 degrees. Similarly, if I asked you what's the measure of this semicircle, the semicircle, which is half of 360, is also 180 degrees. There's a relationship between this angle and that arc. Central angles are the measures of a central angle equals the measure of its corresponding arc. So a central angle is congruent to the measure in degrees is congruent or equal to the arc, the corresponding arc. A central angle is a central angle. It has its vertex at the center of the circle. So BAC is a central angle. I can draw other central angles. So let's call this circle W. In circle W, okay, so in circle W, angle AWB is a central angle. Okay, it's a circle whose center is also the vertex of an angle. So, it's an angle whose vertex is the center of the circle. So let's say angle AWB was 90 degrees. That means, so if angle AWB is 90 degrees, that means the measure of minor arc AB is also 90 degrees. When I say you can measure in units, that's a little different, and we're not going to go into that now, but just keep a note that when we measure in degrees, it's very general, okay? And we'll talk about that more in class. So in this problem, we're asked to find the measure of all of these arcs and angles. So if I look at the picture, first of all, I need to be told in my direction, so I'm going to tell you that this is circle B. That is helpful because if you know it's circle B, then B is the center of the circle. It says that the measure of arc AC is 150 degrees. It wants me to find these other things. So let's first identify some other things we know in the picture. If B is the center, that means that AD is a diameter, which means that on this side, if this is a diameter, that it splits it in half, so half of 360. You know that AED on this side would be 180 degrees. We also know on the other side, we highlight in a different color. I'm going to highlight in blue. Everything I've just highlighted in blue is 180 degrees. Similarly, you see a linear pair here. So if ABC, we know that that would be 150 because the central angle is congruent to its arc. That means that this angle here would have to be 30. If the angle here is 30, That means its corresponding arc would also have to be 30 degrees. So what I did to figure things out, I knew that the central angle and the corresponding arc are congruent. I knew that semicircles 180 degrees, so I used that to help me figure the missing sides, sorry, not sides, but arcs and angles. Let's do another problem. In this problem it says, in circle D, so that helps me know that this is the center, meaning CDA is a central angle. The measure of arc ABC is 10x plus 2y. So that means this whole thing is 10x plus 2y. Ooh, I was given a number. Look, A to C, that's 120. Oh, that's so helpful. That's helpful because if this is 120 degrees, well, 360 minus 120 would give me 240. So that means on the other side of the circle, this major arc would be 240. So not only do I know that ABC equals those variables, but I also know that it's 240 degrees. That's helpful. Let's look to see what else. We were told that ADC is 3x plus y. Well, I know that in a circle that the central angle and its corresponding arc are congruent. So if the arc is 120 degrees, that means that the central angle is also 120 degrees. That is helpful because now I know that 3x plus y is 120. So this will be a systems of equations problem. Okay, so I'm going to multiply the bottom by negative 2. So I get 10x plus 2y equals 240. I get negative 6x minus 2y equals negative 240. When I combine, I get 4x equals 0. So x is 0. So it says solve for x and y. I know that x is 0. If I want to plug it in somewhere, I can plug it into one of the original equations. So let's plug it in here. So 3 times 0 plus y equals 120, which gives me y is 120.